Hello everyone and welcome to my presentation of my new project called Reserve. It is a cloud-based reservation application for restaurant and diners to manage reservation. So let's explore how Reserve plans to make reservation easier and faster for both customer and restaurant staff. I will demonstrate or use knowledge that I gained from the course and also from the course material called Engineering Software Products and Introduction to Modern Software Engineering. My main goal with Reserve is to make booking in restaurant easy for both restaurants and customer. I want to make sure everything runs smoothly, make everything make customer happy and help restaurants make more money and avoid booking mistake by using my application. So my target audience includes individual looking to make dining reservation conveniently, food lovers who wants a simple way to get a table, and groups groups organizing events at restaurants. Also restaurant workers like manager, hosts, and admins can make their job easier with more organized with Reserve. Now let's talk about how I applied an agile development approach to this project. In Agile, we organize tasks into a product backlog, which is a list of features or functionalities we want to develop. Each item in the backlog is called a user story, representing a specific user need or requirement. Here are some examples of user stories from my product backlog. So, like as a customer, I want to select for available date, time, party size, and location so that I can make a reservation. As a restaurant staff member, I want to confirm or reject reservation based on availability and preference. By breaking down the project into user stories, we can prioritize and tackle them in manageable increments, ensuring that we deliver value to user at every stage of development. In this project, I use Sprint, which is breaking our work into small manageable chunks. A sprint is like a short, focused burst of work, typically lasting a few days to a couple of weeks. During each sprint, we talk about specific tasks or user stories from our project backlog and aim to deliver value incrementally. In my project, designing the software architecture was important. I chose React for the front end because it's widely used and easy to maintain and offers a great user experience. For the back end, I chose Python HTTP for the server due to its simplicity, flexibility, and seamless integration with our chosen front-end framework. As for the database, MySQL was our choice because of its reliability, scalability, and strong performance capabilities. These architectural choices were made to ensure scalability, maintainability, and optimal performance for my application. This project is deployed in a cloud service like AWS. In this presentation, I will show how I integrate my project in the cloud. First, we need to launch a new instance and let's put some name. Let's choose Ubuntu and then Let's change this to medium. Let's expose the port 3000 and we can launch our instance. So we can see that our instance is created. We can visit that. What we're gonna do next is I have to connect to the instance. I have to connect it. We have to update it first. And after that, we have to install the Git. So, because after that, we have to install the Docker, because Docker is not installed in here. Yes. So we have to install the Docker Compose as well. After installing the Docker and Docker Compose, push my, I have to clone my repository. And then let's just paste my, as you can see, here's my codes. And what we're going to do now is we're going to, so now we have to do Docker Compose. So this process takes time, but at the end we can see that the containers are running in this instance. Okay, that takes time, but as we can see that all of my container is running in the cloud. You can see that the database and the front end is running, and you can see that the container is all right. So uploading our project to the cloud significantly improves its scalability and reliability and maintenance efficiency. In this project, I use microservice architecture. I use services like user service, authentication service, and reservation handling service. Each of these services works independently and communicate with each other as needed. For example, the user service handles user related tasks. The authentication service takes care of user login and security, and reservation service manages booking functionalities. In this project, I prioritize security and privacy for both customer and staff by implementing hash authentication and JWT. Here for example, when user register, their password is hash using this library. This ensures that passwords are never stored in plain text, reducing the risk of unauthorized access to user accounts. For authentication, I use token-based authentication using JWT. When successful authentication, users receive a JWT containing their username and role. This token is stored in the browser and used to authenticate subsequent requests. This approach adds an extra layer of security by verifying authenticity of each request and preventing unauthorized access. Now, let's put these services to test. I've created tests to ensure they are functioning properly. I will show one test in each service and then run all the tests for each service afterwards. So this test focuses on the registration process for staff members. We're simulating a scenario where a new staff member is signing up to join our system. We send post to we send a post request to the staff registration endpoint with a mock data including username, password, email, role, and additional information. Then we check the response from the server to ensure that the registration was successful. If the status code is 201 and the response message confirms stop registration successful, then the test passes, indicating that our stop registration function is working as expected. Now, this test focuses on the customer login functionality. We're simulating a scenario where a customer is attempting to log into our system. We send a post we send a post request to the customer login endpoint with um, mock login data. Then we check the response from the server to ensure that the login attempts is handled correctly. If the status is 40 if the status code is 401, it indicates that the login attempt was unauthorized, which is expected behavior for these tests. So this test focuses on updating the status of the reservation. We're simulating a scenario where a customer status need to be changed, such as confirming it. We send a put request to the update status endpoint with mock data specifying the new status. Then we check the response from the server to ensure that the status update was successful. If the status code is 200 and the response message confirms reservation status updated successfully, then the test passes, indicating that our reservation status update functionality is working as expected. The key features that I managed to implement are view and manage reservation details and update reservation statuses and maintain a centralized database of customer and staff profiles. So to demonstrate the user side of this app, let's first register as a customer. And once we are done, we can log in as a customer and start reservation. And then we can log in. And so after we can log in, we can now make a reservation. We successfully create a reservation. So for step side, we have to do the same thing as on the step side. We have to register first, and after that, we can log in and go to the reservation to see all the reservation we have for our restaurant. We can see here all of our reservation for our restaurant. Now we can see all the reservation we have in here in the stop side. We can manage our reservation, we can accept them, we can deny our reservation and delete it. We can accept reservation. Let's make a reservation again. So we can see here's our reservation that we made earlier from the customer side. And as you can see, this is the view on the stop side, in the admin side, or the owner of the restaurant. He can manage the reservation, accept reservation, delete reservation. As you can see, the status is updated based on our action. And for security purposes, the customer cannot go into the admin side or stop side. We can test that functionality here. Like for example, when the user wants to go to the um, reservation side where the in the admin page, he can't go there. The website will the application will redirect the customer to the home page. The customer can only make reservation, and that's all the customer can do. So as a customer, after we make a reservation, we can log out in the application, and this log outs the customer um, from the website. And also for the admin side, log out functionality is available too. So the challenges I face. So one of the challenges I encountered was connecting the front end and back end and database component of my application, and ensuring smooth communication between these layers required careful coordination and testing. And I had a hard time dockerizing the application, setting up the YAML file, and managing dependencies. The lesson I learned is through this project, I gained valuable insight into deploying application on cloud AWS instances, and I learned how to generate and verify and manage JWT tokens to authenticate users securely. And the potential areas for future development is introducing real-time update feature using technologies like WebSockets and enable instant notification and dynamic content updates for user. Thank you so much for watching this presentation.